Hello, in this lecture we'll answer on two questions. In the first question we'll find out the radius of this quarter circle. In the second question we'll find out the size of this angle, angle theta, that is equal to angle ABC. Okay, so we'll start with the first question. In the drawing we have a quarter circle. You know that line segment BC equals to 9 units, line segment CD equals to 16 units, line segment DL equals to 12 units. This angle ABC equals to this angle DBC equals to 90 degrees, this angle BCD equals to 90 degrees, and this angle CDL also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. Okay, first of all, because of the fact that this is a quarter circle, then point O is the center of the quarter circle, so I write it down. Here, point O is the center of the quarter circle. And here this angle BOF equals to 90 degrees. It is true in any quarter circle. And side AO equals to side OF, and both sides are defined as the radii of this quarter circle. So here side OA is the radius of this quarter circle, so we'll define the radius of the quarter circle as R, therefore OA equals to R, and here OF will be also equals to R, that is the radius of the quarter circle. Okay, so in the next step we'll extend the straight line CD by a straight line until it touches the radius of the quarter circle, that is OF, and we will define the touching point of the extended CD and the radius OF as point M. Point M is the touching point of the extended straight line CD and the radius OF. Okay, by doing this construction, actually we created quadrilateral BCOM, and inside quadrilateral BCOM, this quadrilateral, we have 1, 2, 3 right angles. I repeat again, inside quadrilateral BCOM, we have 1, 2, 3 right angles. So I will write it down. Inside quadrilateral BCOM, we have 3 right angles, and the sum of 3 right angles is 90 degrees times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO, this angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees from this equation, and we will get that the missing angle DMO is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So it is actually a right angle. So this angle, it is a right angle. That is to say it is equal to 90 degrees. So we actually found out that all the angles inside quadrilateral BCOM are right angles. So quadrilateral BCOM has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral BCOM as a rectangle. Quadrilateral BCOM is a rectangle because it has 4 right angles. Okay. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle BCOM, they are equal to each other. It means that BC equals to OM. Side BC equals to OM in rectangle BCOM. BC equals to OM. According to the rule that the opposite sides of a rectangle are equal to each other, BC equals to OM. But according to what is given us the question, BC equals to 9 units. So we can write here that BC equals to 9. And from this equation, 9 equals to BC equals to OM. We will derive that OM is also equals to 9 units. Okay, OM equals to 9 units. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, so in rectangle, if OM equals to 9 units, so we found out that in rectangle BCOM, OM equals to 9 units, and here we know that it is given us the question that CD that is equal to 16 units, it is a straight line. We extended the straight line CD by a straight line and we got line segment CD. And it is obvious that when you extend the straight line by a straight line, the result must be also a straight line. So when you extended the straight line CD by a straight line, we got line segment CM, therefore CM is a straight line. So we can write down that CM is a straight line. Okay, CM is a straight line. So here, if we focus on this side of the straight line CM at point D, we know that we have the rule that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So CD is a straight line, so if you focus on the upper side of the straight line CD at point O, then the sum of the angles on the upper side of CD at point O must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Okay? So this is rule number 3. So we can implement rule number 3 in our drawing, because in our drawing we have the straight line CM So if we focus on this side of the straight line CM at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have on this side of CM at point D? We have here this angle that is equal to 90 degrees, plus this angle that is actually angle MDL. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. That is actually rule number 3. We'll subtract 90 degrees from this equation, and we'll get that the missing angle MDL, it is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. Okay, so here, this angle MDL equals to 90 degrees. It is a right angle. Likewise, we know that OF, line segment OF, is the radius of the quarter circle. OF equals to R, it is the radius of the quarter circle. So as a radius of the quarter circle, it is absolutely a straight line. So you can write down that OF is a straight line as the radius of the quarter circle. OF is a straight line. So if we focus on the upper side of the straight line OF at point M, we focus on the upper side of the straight line OF at point M, so the sum of the angles here must be equal to 180 degrees. So which angles we have on the upper side of OF at point M? We have here 90 degrees, plus this angle that is actually angle DMF. In total, the sum of those two angles must be equal to 180 degrees, according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we subtract 90 degrees from this equation, and we get that the missing angle DMF is equal to 180 degrees minus 20 degrees. It is equal to 90 degrees. So we find out that the missing angle DMF equals to 90 degrees. This angle equals to 90 degrees. So in the next step, from point L, we will draw perpendicular on OF. I repeat again, from point L, we will draw perpendicular on the radius OF. So here, this angle equals to 90 degrees according to our construction. And we will define the touching point of the perpendicular from point L and OF as point N. So by drawing this straight line, this perpendicular, we created quadrilateral DLMN. And in quadrilateral DLMN, inside quadrilateral DLMN, we have one, two, three right angles. So repeat again. inside quadrilateral DMNL, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actually angle DLN. In total, the sum of those 4 angles, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we get that the missing angle DLN, is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees, so it is actually a right angle. So this angle equals to 90 degrees. It is a right angle. So we actually found out that inside quadrilateral DLMN, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral DLMN as a rectangle. Okay. And we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of a rectangle DLMN are equal, they are equal to each other. We'll define side DM as H. Side DM equals to H according to our definition. So here side DM must be equal to side LN according to the rule that the opposite sides of a rectangle are equal to each other. So I write it down, side DM must be equal to side LN. Okay. I'll repeat again, side DM must be equal to side LN according to the rule that the opposite sides of a rectangle are equal to each other. But according to our definition, side DM equals to H. So you can write here that DM equals to H. And from this equation, H equals to DM equals to LN. We will derive that side LN is also equals to H. This side LN is also equals to H. Here we can write down that side LN is also equals to H. It is very important to say that here ON is shorter than the radius OF. You can see here, actually points N and F, they are very close, but still line segment ON is shorter than the radius OF. Okay, therefore it is very important to say that ON, it is not the radius of the quarter circle, but OF is the radius of the quarter circle that is a little bit bigger than line segment ON. Okay, so here, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that side DL equal to side MN. Side DL equals to side MN according to the rule that the opposite sides of rectangle are equal to each other. But it is given as the equation that side DL equals to 12 units. So we write here that side DL equals to 12 units. And from this equation 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Here side MN also equals to 12 units. And here you can see that MN, the length of line segment MN, is OM plus MN. OM is 9 and MN is 12. 9 plus 12 is 21. And it is very important to emphasize that 21, it is not the radius of the circle, but here OF is the radius of this circle. That is actually because of the fact that points N and F, they are very close to each other. It means that the radius OF will be a little bit greater than ON. That is to say, the radius OF of the quarter circle will be a little bit greater than 21, that is the length of line segment ON. Okay? So here, in the next step, we'll join points O and C together by a straight line. Here, point O is the center of the quarter circle. Point C is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OC is the radius of this quarter circle that is equal to R according to our definition. So, in the next step, we'll implement the Pythagoras theorem on the right green triangle, triangle OMC. Okay? On the right green triangle, triangle OMC. My PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle OMC is OC, therefore the square of the hypotenuse is OC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OM squared plus CM squared. Okay, this is point C plus CM squared. I'll repeat again. In the right triangle, triangle OMC, according to the Pythagoras theorem, OC squared equals to OM squared plus CM squared. Okay? So here, OC equals to R, therefore OC squared is R squared, and it is equal to OM squared. OM equals to 9, therefore OM squared is 9 squared, that is 81, plus CM squared. What is the length of CM? It is very easy to see from the drawing that CM equals to CD plus DM. Again, CM equals to CD plus DM. So CM equals to CD, that is 16, plus DM, that is 8. So in total, CM equals to 16 plus 8. CM equals to 16 plus 8. Therefore, CM squared will be equal to 16 plus 8 squared. So in conclusion, I found out that according to equation number 1, R squared equals to 81 plus 16 plus 8 squared. Here we will open the brackets on this side of equation number 1, and we will get that according to equation number 1, R squared equals to 81 plus 16 plus 8 squared equals to 16 squared, that is 256, plus 8 squared, plus 2 times 16 times 8 is 32H. So here we found out that according to equation number 1, R squared equals to 81 plus 256 is 300 37 plus h squared plus 32h. So according to equation number 1, we found out that r squared equals to 337 plus h squared plus 32h. In the next step, we join points O and L together by a straight line. By joining points O and L by a straight line, we created the right triangle, triangle OLF. So this green orange triangle, triangle OLN, is the right triangle because this angle equals to 90 degrees according to our construction, angle LNO. Now we will implement the Pythagoras theorem on the right orange triangle, triangle OLN. But before this, you know that OL is the hypotenuse of the orange triangle, OLN. So point O is the center of the quarter circle. Point L is the point of the quarter circle itself. That is to say, OL is the radius of the quarter circle that is equal to R according to our definition. So OL equals to R. Now we will implement the Pythagoras theorem on the orange right triangle, triangle OLN. So in the orange right triangle, triangle OLN, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle OLN is OL, therefore the square of the hypotenuse is OL squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to ON squared plus LN squared. I'll repeat again. According to the Pythagoras theorem, in the orange triangle, triangle OLN, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, OL squared equals to ON squared plus LN squared. Okay. OL is the radius of the quarter circle that is equal to R, therefore OL squared is R squared. And it is equal to ON squared. ON equals to OM plus MN, that is to say ON equals to OM, that is 9, plus MN, that is 12. 9 plus 12 is 21. So ON equals to 21, therefore ON squared is 21 squared, plus LN squared. LN equals to H, therefore LN squared equals to H squared. So in conclusion, we found out that according to equation number 2, R squared equals to 21 squared plus H squared. 21 squared is 441, so I write it down. I found out that according to equation number 2, R squared equals to 21 squared is 441 plus H squared. So we actually have here two different equations, two different expressions for R squared. Equation number 1 and equation number 2. Therefore, in the next step, we'll create equation number 3 that states that R squared according to equation number 1 must be equal to R squared according to equation number 2. Okay? So here we have the equation number 3 that states that R squared according to equation number 1 must be equal to R squared according to equation number 2. Okay? R squared equals to R squared. So r squared, according to equation number 1, is 337 plus h squared plus 32h, and it must be equal to r squared according to equation number 2, and r squared according to equation number 2 is 441 plus h squared. Okay, so here we have h squared on both sides of equation number 3, so h squared will get cancelled. What is left from equation number 3 after we cancelled h squared? What is left, it is actually, we have here 337 plus 32h equals to 441. Here we'll subtract 337 from this equation, equation number 3, and we'll get that according to equation number 3, here we have 32h equals to 441 minus 337, it is equal to 104. So we found out that according to equation number 3, 32h equals to 104. Here we'll divide this equation by 32 and we'll get that h equals to 104 over 32. 104 over 32 is 3.25 units. So we found out that h equals to 3.25 units. Now we will substitute h in equation number 2 by 3.25 units. And we get that according to equation number 2, according to equation number 2, we have r squared equals to 441 plus h squared. And we have already found out that h equals to 3.25. So if h equals to 3.25, it means that h squared is 3.25 squared, that is 10.5625. So in conclusion, we found out that according to equation number 2, r squared equals to 441 plus 10.5625. So according to equation number 2, we found out that r squared equals to 441 plus 10.5625 equals to 451.5625. Here we take a root out of this equation, equation number 2, and we get that r equals to the square root of 451.5625, that is actually 21.25 units. So we found out that the radius of the quarter circle equals to 21.25 units, that is actually a little bit greater than 21 units, that is the length of line segment ON. Actually, the radius of the quarter circle that is equal to 21.25 units, it is greater than line segment ON by 0.25 units. Okay, so they are actually very close to each other in their lengths. Okay, so we found out that the radius of this quarter circle, it is equal to 21.25 units. Okay, so we finished with the first question. In the next step, I will present to you the second question, and we will solve the second question in two different methods. So in the drawing we have triangle ABC. This is triangle ABC. Angle ACB equals to 40 degrees. Angle ATC equals to 80 degrees. Side AC equals to Y units. Side AB equals to X plus Y units. Side DC equals to X units. And the angle that we are looking for is angle ABC that is equal to theta. So our mission is to find out the size of this angle, angle theta, that is equal to actually angle ABC. Okay, so in the first method we will start with a construction. We will extend side BC by a straight line in Y units. Okay, I repeat again, we will extend the straight line BC in Y units. This is to say, here if this point is point E, it means that CE equals to Y units according to our construction. Okay, in the next step we'll join points A and D together by a straight line. So actually by doing this construction we created here triangle ACE. So I'll copy triangle ACE in the new page and we'll analyze triangle ACE. So this is triangle ACE that I copied from the original drawing. CE equals to Y, AC also equals to Y. And here both sides AC and CE are equal to Y, therefore they are equal to each other. So here side AC equals to side CE. They are both equal to Y, therefore they are equal to each other. So AC equals to CY. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have those two angles and they must be equal to each other according to the rule that I mentioned. Okay, so here side AC, angle AC CAE, this angle must be equal to angle AEC. Why? Because they are located in front of equal sides, therefore they are also equal to each other, angle AEC. So if we define angle AEC as alpha, so here angle AEC equals to alpha, then from this equation angle CAE equals to angle AEC equals to alpha, we will derive that angle CAE is also equals to alpha. Angle CAE is also equals to alpha. So we found out that those two angles are equal to each other, they are both equal to alpha. So here, from the drawing, we can see that this angle, angle ACB, is equal to 30 degrees. So I will draw the angle here. This angle, angle ACB, equals to 40 degrees, according to what is given as the question. And in the next step, I will present to you the exterior angle theorem. What is an exterior angle theorem? According to the exterior angle theorem, if we have triangle ABC, that could be any triangle. This is triangle ABC. In triangle ABC, we have three angles, alpha, beta, and gamma. Those three angles, alpha, beta, and gamma, they are defined as an interior angles. Why? Because they are inside triangle ABC. Therefore, they are defined as the interior angles. They are interior angles, while this angle ACD, this angle ACD is defined as an exterior angle, so I will define it as angle E. So the angle E that is equal to angle ACD, this angle is defined as an exterior angle. Why? Because it is located outside triangle ABC. Okay? So what is the size of the exterior angle, angle E? The size of the exterior angle, angle E, according to the exterior angle theorem, it is equal to the sum of the two interior angles that are not adjacent to it. Here, angle gamma is adjacent to angle E, therefore it is not this angle, but the two other interior angles that are not adjacent to it are alpha and beta. And the sum of those two angles, alpha and beta, is alpha plus beta. So in conclusion, we found out that the size of the exterior angle, angle E, is equal to alpha plus beta. That is to say, it is equal to the sum of the two interior angles that are not adjacent to it. So in conclusion, we found out that according to the exterior angle theorem, the exterior angle, angle E, equals to alpha plus beta. Now we will implement the exterior angle theorem in this triangle, triangle ACE. Those two angles, alpha and alpha, they are both defined as an interior angles of triangle AC because they are located inside triangle ACE. So this angle, angle ACB, is defined as an exterior angle. So the size of the exterior angle, angle ACB, is equal to the sum of the two angles that are not adjacent to it. This angle is adjacent to angle ACB. And the two other angles, the two other interior angles that are not adjacent to it are those two angles. That is to say, they are alpha and alpha. So the size of the exterior angle ACB will be equal to alpha plus beta, that is to say, it is equal to alpha plus alpha. That is to say, it is equal to the sum of the two other interior angles that are not adjacent to it. So angle ACB equals to alpha plus alpha, that is 2 alpha. But we know that angle ACB equals to 40 degrees. So we can write here that 40 degrees equals to angle ACB, and 40 degrees equals to 2 alpha. So here we found out actually that 2 alpha equals to 40 degrees. Here we will divide this equation by 2 and we get that alpha equals to 40 degrees over 2 is 20 degrees. So we found out that alpha equals to 20 degrees. Here alpha equals to 20 degrees and here also angle alpha equals to 20 degrees. So here we can put in the triangle the value of angle CEA. Angle CEA equals to alpha, that is equal to 20 degrees. And we already found out that angle CAE that is equal to alpha, angle CAE that is also equal to alpha, it is also equal to 20 degrees. Okay, we'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees. This angle equals to 40 degrees. 40 degrees plus 80 degrees is 120 degrees. So the sum of the two angles in triangle ADC equals to 120 degrees. So the third angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle, triangle ADC, to 180 degrees. This angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees will be equal to 180 degrees. So this angle equals to 60 degrees. In the next step, I will copy the right triangle. I will copy triangle ADE in a new page and we will analyze triangle ADE. Okay, so this is triangle. Call it triangle ADE. This is triangle ADE. Angle DAE, this angle equals to 60 degrees plus 20 degrees. Here, this angle DAE equals to 60 degrees plus 20 degrees, that is 80 degrees. Angle ADE, this angle equals to 80 degrees according to what is given as the question. Side DE, what is the length of side DE? From the drawing it is very easy to see that DE equals to DC plus CE. DE equals to DC plus CE, that is to say DE equals to DC, that is X, plus CE, that is Y. So DE equals to X plus Y. DE equals to X plus Y. DE equals to X plus Y. Okay. So here, this is triangle ADE. In triangle ADE, those two angles are equal to each other, they are both equal to 80 degrees, therefore they are equal to each other. And according to the rule that in front of equal angles in the triangle there are equal sides, we get that in front of this angle we have side DE, and in front of this angle we have side AE. And because of the fact that those two sides, side DE and side AE, are located in front of equal angles, they are also equal to each other. That is to say, side DE equals to side AE. Side DE equals to side AE. But side DE equals to X plus Y according to what we have already found out. Here we can write down that side DE equals to X plus Y. And from this equation, X plus Y equals to DE equals to AE, we will derive that side AE is also equals to X plus Y. Here, side AE is also equals to X plus Y. In the next step, I'll copy the big triangle ABE in this page and we'll analyze triangle ABE. Okay, so this is triangle ABE. So this is triangle ABE. Let's copy it from the original drawing. According to what is given as the question, side AB equals to x plus y units. According to what we have already found out, we just right now found out that side AE is also equals to x plus y units. According to what is given as the question, angle ABE equals to theta. And we have already found out that this angle AEB equals to 20 degrees. Okay? So actually, triangle ABE is an isosceles triangle. Why? Those two sides are both equal to x plus y, therefore they are equal to each other. So I write it down. Here, side AB equals to side AE. Both sides are equal to x plus y, therefore they are equal to each other. Okay, side AB equals to side AE. But according to the rule that in front of equal sides in the triangle there are equal angles, we get that in front of side AB we have angle that is equal to 20 degrees. And in front of side AE we have this angle that is equal to theta. And according to the rule that in front of equal sides in the triangle there are equal angles, it means that those two angles are equal to each other. Why? Because they are located in front of the equal sides, side AB and side AE. Therefore, they are also equal to each other. So in conclusion, we found out that the size of angle theta is equal to 20 degrees. So that is the answer to the question, that angle theta equals to 20 degrees in its size. This angle theta equals to 20 degrees in its size. Okay, we finished with the first method. In the next step, I'll present to you the second method. In the second method, we'll focus on triangle ADC. In triangle ADC, we have this angle that is equal to 80 degrees, this angle equals to 40 degrees, so the sum of those two angles is 80 degrees plus 40 degrees, that is 120 degrees, therefore this angle must be equal to 60 degrees in order to complete the sum of the angles in this triangle ADC to 180 degrees. This angle must be equal to 60 degrees because 60 degrees plus 120 degrees will be equal to 180 degrees. Okay. In the next step, we define side AD as A, and I will present to you the law of sines, and we will implement the law of sines in triangle ADC and also in triangle ABD. So what is the law of sines? The law of sines is true in any triangle. So I write down that in any triangle So we're talking about the law of sines. So here, this triangle ABC could be any triangle. Side BC equals to A units in its length, side AC equals to B units in its length, and side AB equals to C units in its length. Then, according to the law of sines, we get that the following equation is true in this triangle ABC. Here, A over sine A. Here, capital A is the size of angle BAC, equals to B over sine B. Here, capital B equals to the size of this angle ABC, and it is equal to C over sine C, and capital C equals to angle ACB. Okay, so you can also write the angles inside the triangle itself. This is angle, this is capital B, and this is capital C. Okay, so A over sine A equals to B over sine B equals to C over sine C. Okay, now we will implement the law of sines in this triangle ADC. So here we have triangle ADC. So according to the law of sines, we'll implement it on this triangle ADC. This is triangle ADC. According to the law of sines, we'll get that AD over sinus 40 degrees equals to DC over sinus 60 degrees, and it is equal to AC over sinus 80 degrees. Okay, I'll repeat again. In triangle ADC, AD over sinus 40 degrees equals to DC over sinus 60 degrees, and this also equals to AC over sinus 80 degrees. Okay, so equation number 1 is the implementation of the law of sines in this triangle ADC. So here AD equals to A, so we substitute AD by A, and we get that A over sinus 40 degrees equals to DC. DC equals to X, so we substitute DC by X, so it is X over sinus 60 degrees, and it is equal to AC. AC equals to Y, therefore we'll substitute AC by y, so it is y over sinus 80 degrees. Okay. So actually, in equation number 1, we have three expressions that are equal to each other, so we can define the value of each expression to k, and we can write down that all those three expressions are equal to k. Why? Because they are equal to each other. So all the expressions here, all the three expressions, they are all equal to k because they are equal to each other. And from this long equation, we will derive the first equation, that this expression equals to k. So this will be equation number 1, that a over sinus 40 degrees equals to k. Here we will multiply this equation number 1, by sinus 40 degrees, and we get that according to equation number 1, a equals to k times sinus 40 degrees. Then we will derive the second equation from this long equation number 1. Here, this expression is also equals to k, so we write it down. This will be equation number 2. So according to equation number 2, we actually found out that x over sinus 60 degrees equals to k. Here we multiply this equation number 2, by sinus 60 degrees, and we will get that according to equation number 2, x equals to k times sinus 60 degrees. So we actually found out the value of x. And finally, from the long equation number 1, we will derive that this expression is also equals to k. Okay, so here we create the equation number 3 that states that y over sinus 80 degrees equals to k. So here we multiply this equation number 3, by sinus 80 degrees, and we will get that according to equation number 3, y equals to k times sinus 80 degrees. Actually, here we found the values of x, y, and a. We have the values of x, y, and a. So here, in the next step, we will focus on triangle ABD, but before that, we will find out the size of this angle ADB. Actually, we know the triangle side BC is one side of triangle ABC. So BC is the side of a triangle, it is absolutely a straight line. BC is a straight line. as the side of triangle ABC, it must be a straight line. So BC is a straight line. So we will focus on the upper side of the straight line BC at point D. So on the upper side, on the straight line BC at point D, the sum of the angles must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of BC at point D? We have here this angle that is equal to 80 degrees plus this angle that is actually angle ADB. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. So 80 degrees plus angle ADB equals to 180 degrees. Here we'll subtract 80 degrees from this equation, and we will get that the missing angle ADB, is equal to 180 degrees minus 80 degrees. It is equal to 100 degrees. So we found out that the missing angle ADB, this angle equals to 100 degrees. Now we will implement the law of sines in this triangle ADB. Okay, so here, according to the law of sines, in this triangle ADB, so I write it down, in triangle ADB, according to the law of sines, we will get that here AD over sinus theta, AD over sinus theta equals to AD over sinus theta equals to AB over sinus 100 degrees, equals to AB over sinus 100 degrees. I'll repeat again. Question number 2 is the implementation of the law of sines in this triangle ABD. According to the law of sines, AD over sinus theta equals to AB over sinus 100 degrees. Repeat again here. According to equation number 2, we found out that AD over sinus theta equals to AB over sinus 100 degrees. So here AD equals to A, therefore we'll substitute AD by A, and AB equals to X plus Y, therefore we'll substitute AB by X plus Y. Okay, and we'll get that according to equation number 2, AD is A, therefore A over sinus theta equals to AB. AB is X plus Y, so we substitute AB by X plus Y over sinus 100 degrees. Okay. Now we'll substitute A by the value that we found for A, we'll substitute X and Y by the values that we found out for X plus Y. and we'll get that according to equation number 2, here A is k times sinus 40 degrees, so we'll substitute A by k times sinus 40 degrees over sinus theta, and it is equal to x. We already found out that x equals to k times sinus 60 degrees plus y, and we already found out that y equals to k times sinus 80 degrees over sinus 100 degrees. So here we have k on both sides of equation number 2, so k will get cancelled. And what is left from equation number 2 after we cancelled k? We have here, in this side of the equation, we have sinus 40 degrees over sinus theta, that is equal to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. So here we'll cross multiply this equation, equation number 2, and we'll get that according to equation number 2, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 80 degrees plus sinus 60 degrees. Okay. In the next step, we will divide the equation number 2 by sinus 80 degrees plus sinus 60 degrees, and we will get that according to equation number 2, actually, yes, so we'll divide the equation number 2 by sinus 80 degrees plus sinus 60 degrees, and we get that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Okay. We'll use the trigonometric identity that sinus 2a equals to 2 times sine a cosine a. We use this trigonometric identity for sine 40 degrees. Sine 40 degrees is equal to sine 2 times 20 degrees, and according to this trigonometric identity sinus 2a equals to 2 sine a cosine a, we'll get that sinus 2 times 20 equals to 2 times sine 20 times cosine 20. That is to say, we can substitute sinus 40 degrees by here, sinus 40 degrees, according to this trigonometric identity, it is equals to 2 times sinus 20 degrees times cosine 20 degrees. Therefore, we can substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees. Okay. And we will use the trigonometric identity of sine 90 degrees plus theta, that is equal to cosine theta. Use this trigonometric identity for sine 100 degrees. Sine 100 degrees is equal to sine 90 degrees plus 10 degrees, and sine 90 degrees plus 10 degrees, according to the trigonometric identity, that sine 90 degrees plus theta equals to cosine theta. Therefore, sine 90 degrees plus 10 degrees, according to this trigonometric identity, will be equal to cosine 10 degrees. So in conclusion, we found out that sine 100 degrees equals to cosine 10 degrees. So I write it down. We actually found out that sine 100 degrees equals to cosine 10 degrees. That is to say, we can substitute sine 100 degrees by cosine 10 degrees. And the second thing that we have already found out that sine 40 degrees equals to 2 sine 20 degrees by cosine 20 times cosine 20 degrees. So we substitute sine 40 degrees by 2 times sine 20 degrees times cosine 20 degrees. Okay. So we have equation number 2 that states that sinus theta equals to sinus 40 degrees, but sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. So we substituted sinus 40 degrees by 2 times sine 20 degrees times cosine 20 degrees. And according to equation number 2, we have sinus 40 degrees times sinus 100 degrees, and we substitute sinus 100 degrees by cosine 10 degrees. Okay? And we have to divide all, according to equation number 2, we have to divide all by sine 80 degrees plus sine 60 degrees. Okay? Now, we have also trigonometric identity for sinus 80 degrees plus sinus 60 degrees. Here we have the trigonometric identity that states that sinus d plus sinus c is equal to 2 times sinus c plus d over 2 times cosine, actually it is sinus d plus c over 2, sinus d plus c over 2 times cosine d minus c over 2. Okay, so we'll use this trigonometric identity in order to find out the value of sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, we will get that sinus 80 degrees plus sinus 60 degrees is equal to 2 times sinus 80 degrees plus 60 degrees, that is 140 degrees, and 140 degrees over 2 is 70 degrees, times cosine d minus c is 80 degrees minus 60 degrees is 20 degrees, and 20 degrees over 2 is 10 degrees. So in conclusion, we found out that sinus 60 degrees, sinus 80 degrees plus sinus 60 degrees, it is equal to 2 times sinus 70 degrees over cosine 10 degrees. So we substitute sinus 80 degrees plus sinus 60 degrees in equation number 2 by 2 times sinus 70 degrees times cosine 10 degrees. So we'll do it now and we'll get that according to equation number 2, sinus theta is equal to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees over sinus 80 degrees plus sinus 60 degrees, but we have already found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Okay. So in this equation number 2, we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And we also have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will also get cancelled. And found out that according to equation number 2, sinus theta equals to, here, what is left after, from equation number 2, after we cancel those two expressions, we have here sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. So in conclusion, found out that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. And we will use the last trigonometric identity for the value of sinus 70 degrees according to the following trigonometric identity. Sinus 90 degrees minus theta equals to cosine theta. We use this trigonometric identity for sinus 70 degrees. Here, actually, sinus 70 degrees is equal to sinus 90 degrees minus 20 degrees. And according to this trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, we will get that sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees is equal to cosine 20 degrees. Therefore, we can substitute sinus 70 degrees in this equation, equation number 2, by cosine 20 degrees. So we'll do it now and we'll get that according to equation number 2. Sinus theta is equal to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. But we just right now found out that sinus 70 degrees equals to cosine 20 degrees, so we substitute sinus 70 degrees by cosine 20 degrees. So according to equation number 2, we found out that sinus theta equals to sinus 20 degrees times cosine 20 degrees over cosine 20 degrees. So we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled. So what is left from equation number 2 after we cancel cosine 20 degrees? We have here sinus theta that is equal to sinus 20 degrees. And we know that if sinus alpha equals to sinus beta, it means that alpha equals to beta. So if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So we found out that the value of the size of angle theta is equal to 20 degrees according to the second method also. In the next step I will summarize the lecture. We'll start with the first question, of course. So in the drawing we have a quarter circle, 9 segment BC equals to 9 units, 9 segment CD equals to 16 units, 9 segment DL equals to 12 units, angle DBC equals to 90 degrees, angle BCD equals to 90 degrees, and angle CDL also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. Okay, so first of all, because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle, and this angle BOM is equal to 90 degrees, and also side AO is equal to side OF, and both sides, they are the radii of the quarter circle. So we define the radius of the quarter circle as R, therefore OA equals to R, and OF, it is also equals to R. This is the radius of the quarter circle. Both sides are the radii of the quarter circle that is equal to R. So OA equals to R, and OF is also equals to R. Okay, so in the next step, we did the construction. We extended the straight line CD by a straight line until it touches the radius OF of the quarter circle at point M. So point M is the touching point of the extended straight line CD and the radius OF. Okay, so by doing this construction, we created here quadrilateral BCOM. So inside this quadrilateral BCOM, we have 1, 2, 3 right angles. Again, inside quadrilateral BCOM, we have 1, 2, 3 right angles. Repeat again, inside quadrilateral BCOM, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle DMO, it is equal to 90 degrees. So this angle, it is a right angle, it is equal to 90 degrees. So actually we found out that inside quadrilateral BCOM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle if not a square. Therefore, we will relate to quadrilateral BCOM as a rectangle. Why? Because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle BCOM must be equal to each other. That is to say, side BC must be equal to side OM. Side BC must be equal to side OM. And here, it is given as the equation that side BC equals to 9 units, therefore we can write here that BC equals to 9, and from this equation 9 equals to BC equals to OM, we will derive that OM is also equals to 9 units. Here OM is also equals to 9 units. Okay, then actually when we did the construction here, we extended the straight line CD by a straight line. And when you extend a straight line by a straight line, the result must be a straight line. So when you extended the straight line CD by a straight line, the result was the straight line CM, that it must be also a straight line. Therefore, CM is a straight line. This line segment CM is a straight line. And we have rule number 3 that states that the sum of the angles in one side of a straight line is equal to 180 degrees. So CD is a straight line. So if we focus on the upper side of the straight line CD at point O, then the sum of the angles here must be equal to 180 degrees. That is to say, alpha plus beta must be equal to 180 degrees. We can actually implement rule number 3 in our drawing. Why? Because in our drawing we have the straight line CM. So if we focus on this side of the straight line CM at point D, then according to rule number 3, the sum of the angles at this side of the straight line CM at point D must be equal to 180 degrees. So which angles we have at point D, this side of the straight line CM? We have here this angle that is equal to 90 degrees plus this angle that is actually angle LDM. In total, the sum of those two angles must be equal to 180 degrees. I'll repeat again, 90 degrees plus angle MDM must be equal to 180 degrees according to rule number 3. Here we subtracted 90 degrees from this equation and found out that the missing angle MDM equals to 90 degrees. So this angle MDM equals to 90 degrees. Okay, likewise, OF is the radius of the quarter circle, and OF is the radius of the quarter circle. It is absolutely a straight line. So here OF is a straight line, and here if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have on the upper side of OF at point M? We have here this angle that is equal to 90 degrees plus this angle that is actually angle DMN or DMF. So on the upper side of the straight line OF at point M, the sum of the angles must be equal to 180 degrees. That is to say, 90 degrees plus the size of angle DMF. In total, they must be equal to 180 degrees. Here we subtracted 90 degrees from this equation, and we found out that the missing angle DMF equals to 90 degrees. So this angle DMF equals to 90 degrees. In the next step, from point L, we draw perpendicular on the radius OF. I repeat again, from point L, we draw perpendicular on the radius OF. So this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular from point L and OF as N. N is the touching point of the perpendicular from point L and OF. So by doing this construction, we created here quadrilateral DLMN, and inside this quadrilateral DLMN, we have 1, 2, 3 right angles. Inside this quadrilateral, we have 1, 2, 3 right angles. And the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that is actually angle DLN. This angle, in total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle DLN equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. So this angle DLN, is a right angle. Therefore, we actually found out that inside quadrilateral DLMN, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral DLMN as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle DLMN, they are equal to each other. So we define side DM as edge. Side DM equals to edge according to our definition. And according to the rule that the opposite sides of rectangle are equal to each other, so in rectangle DLMN, we will get that side DM must be equal to side LN. side DM must be equal to side LN rectangle DLMN. But according to our definition, side DM equals to edge. So here we can write down that DM equals to edge. And from this equation, edge equals to DM equals to LN, we will derive that side LN is also equals to edge. Here side LN is also equals to edge. Likewise, according to the same rule that the opposite sides of rectangle are equal to each other, we will get that side DL must be equal to side MN in rectangle DLMN. Side DL must be equal to side MN in rectangle DMNN. But according to what is given as the equation, side DL equals to 12 units. So we can write here that DL equals to 12. And from this equation, 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Here, side MN is also equals to 12 units. Okay? So here, actually found out that side ON equals to 9 plus 12, that is 21 units. And the radius of the circle is not equal to 21 units, but it's a little bit longer than ON, because the radius of the quarter circle is OF and not ON. Although points N and F are close to each other, not merged with each other, therefore OF will be a little bit longer than ON, that is 21 units. So the answer to the question we are expecting the result that is a little bit longer than 21 units. The radius of the circle must be, the radius of the quarter circle must be a little bit greater than 21 units because of the fact that points N and points F are very close to each other, but OF is also a little bit longer than ON. Okay, so in the next step we join points O and C together by a straight line. OC is the hypotenuse of the right hand triangle COM, but OC it is also the radius of the quarter circle. Why? Because it starts from the center of the quarter circle, from point O, and ends at point C, that is the point of the quarter circle itself. That is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to R according to our definition. So the hypotenuse OC equals to R. We implement the Pythagoras theorem on the right triangle OCM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OC square equals to OM square plus CM square. In the right triangle OCM, OC square equals to OM square plus CM square. So OC equals to R, therefore OC square equals to R square. And it is equal to OM square. OM equals to 9, so OM square is 9 square, that is 81, plus CM square. What is the value of CM? CM equals to CD plus DM. That is to say, CM equals to CD, that is 16, plus DM, that is 8, so CM equals to 16 plus 8. Therefore, CM square is 16 plus 8 square. So in conclusion, we found out that according to equation number 1, R square equals to 81 plus 16 plus 8 square. Here, we open the brackets of this equation number 1, of this side of equation number 1, and we found out that R square equals to 81 plus 16 plus 8 square. 16 plus 8 square equals to 16 square, that is 256, plus 8 square plus 2 times 16 times 8, that is 32H. Okay, so here we have H, we found out that R square equals to 81 plus 256 plus 8 square plus 32H. Here 81 plus 256 is 337 plus 8 square plus 32H equals to R square according to equation number 1. Then we join points O and L together by a straight line. OL is the hypotenuse of the orange right triangle ONL, but OL is also the radius of the quarter circle. Why? Because it starts from point O, that is the center of the quarter circle, and ends at point L, that is the point on the quarter circle itself. This is exactly the definition of a radius. Therefore, OL is the radius of the quarter circle that is equal to R. So OL, the hypotenuse, equals to R. according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OL square equals to LN square plus NO square. Again, OL square equals to ON square plus LN square. OL equals to R, therefore OL square is R square. Here, NO equals to OM plus MN. So OM equals to 9 and M equals to 12. Therefore, ON equals to 9 plus 12, that is 21. So if ON equals to 21, it means that ON square equals to 21 square. So in conclusion, found out that according to equation number 2, R square equals to 21 square plus H square. So here, according to equation number 2, R square equals to 21 square, that is 441, plus H square. Okay, so we have here two different expressions for R square. We have the first expression in equation number 1, and the second equation, and the second expression for R square in equation number 2. Therefore, we created the third equation that states that R square according to equation number 1 must be equal to R square according to equation number 2. So here we created this equation number 3, that states that R square according to equation number 1 must be equal to R square according to equation number 2. R square according to equation number 1 equals to 337 plus H square plus 32, and it must be equal to R square according to equation number 2, that is equal to 441 plus H square. Here we have H square on both sides of equation number 3, so H square will get cancelled. And we found out that according to equation number 3, 337 plus 32H equals to 441. Here we subtracted 337 from this equation number 3, and found out that 32H equals to 104, because 441 minus 337 equals to 104. So in conclusion, found out that 32H equals to 104. We divided this equation number 3 by 32, and found out that H equals to 104 over 32, that is 3.25 units. So we found out that H equals to 3.25 units. Therefore, we actually put the value of H inside equation number 2. Here, according to equation number 2, R square equals to 441 plus H square. So H equals to 3.25. So if H equals to 3.25, it means that H square will be equal to 3.25 square. That is 10.5625. So we substituted H square in equation number 2 by 10.5625. So we found out that according to equation number 2, R square equals to 441 plus 10.5625, and 441 plus 10.5625 equals to 451.5625. So according to equation number 2, we found out that R square equals to 451.5625. We took a root out of this equation number 2, and found out that the radius of the quarter circle R equals to the square root of 451.5625, that is equal to 21.25 units. So here the radius of this quarter circle, it is a little bit greater than 21, and it is equal to 21.25 units. Actually, it is greater than 0.25 than line segment ON. Okay, we finished with the first question, then I presented you the second question, and we solved the second question in two different methods. In the drawing we have triangle ABC. Here angle ACB equals to 40 degrees, angle ADC equals to 80 degrees, side AC equals to y unit, side DC equals to x, side AB equals to x plus y, and we are looking for angle ABC that is equal to theta. Okay, in the first method we did the construction, we extended side BC by a straight line by y units. So here CE equals to y units according to our construction. Then we added points, we joined points A and D by a straight line. In this way we created triangle ACE. Then I copy triangle ACE in a new page and analyze triangle ACE. This is triangle ACE that I copied from the original drawing. AC equals to y according to what is given as the question, and C equals to y according to our construction. So those two angles, actually those two sides, they are both equal to y, therefore they are equal to each other. That is to say, side AC equals to angle, it's a side CE, they are both equal to y, therefore they are equal to each other. So here side AC equal to side CE, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles must be equal to each other because of the fact that they are located in front of equal sides. So if one angle is alpha, then the other angle must be also equal to alpha. Therefore those two angles, they are both equal to alpha. Angle CAE equals to angle CAE equals to alpha. Okay, then I copied triangle angle ACB from the original drawing. Angle ACB is equal to 40 degrees according to the original drawing. Then I presented to you the exterior angle theorem. What is the exterior angle theorem in a triangle? This triangle ABC could be any triangle. Angles alpha, beta, and gamma are defined as the interior angles from triangle ABC, while angle ACD that is equal to E, it is an exterior angle because of the fact that it is located outside triangle ABC. So the size of this, the size of the exterior angle E, it is equal to the sum of the two interior angles that are not adjacent to it. Angle gamma is adjacent to it, and the two other interior angles that are not adjacent to it are alpha and beta. Therefore, the exterior angle E equals to alpha plus beta in its size. We implemented the angle bisector theorem in our triangle AEC. Angle ACB is the exterior angle, and the size of this exterior angle ACB according to the exterior angle theorem will be equal to the sum of the two interior angles that are not adjacent to it. Those two angles are not adjacent to this angle, therefore the size of the exterior angle ACB will be equal to alpha plus alpha. So angle ACB equals to alpha plus alpha. But it is given us the question that angle ACB equals to 40 degrees, so we can write down here that angle ACB equals to 40 degrees. So from this long equation, we can derive that 40 degrees equals to 2 alpha. 2 alpha equals to 40 degrees. If 2 alpha equals to 40 degrees, we divided this equation by 2 and found out that alpha equals to 20 degrees. Okay, so here, actually, angle CAE, this angle CAE equals to 20 degrees, and this angle AEC, also equals to 20 degrees because both of them are alpha. Then I copied the right triangle, I copied triangle ADE in a new page and we analyzed triangle ADE. So this is actually triangle ADE that I copied from the original drawing. Here, this angle DAE equals to 20 degrees plus 60 degrees, that is 80 degrees, and this angle, so this is angle DAE, that is equal to 80 degrees, and angle AD equals to 80 degrees according to what is given as the question. What is the length of DE? DE equals to DC plus CE, that is to say DE equals to X plus Y. So DE equals to X plus Y. Those two angles are equal to each other, and we have the rule that in front of equal angles in the triangle, they are equal sides. So those two sides that are located in front of equal angles must be equal. Actually, those two sides that are located in front of equal angles must be equal to each other. This is to say, side AE must be equal to side DE because they are located in front of equal angles. But we know that side DE equals to X plus Y. So we can write here that D equals to X plus Y, and from this equation X plus Y equals to D equals to AE, we will derive that AE is also equals to X plus Y. Here AE is also equals to X plus Y. Then I copied triangle ABE in a new page. So we found out that AE equals to x plus y, AB equals to x plus y according to what is given as the equation. Angle ABE equals to theta according to what is given as the equation, and we have already found out that angle AEB equals to 20 degrees. So triangle ABE is an isosceles triangle. Why? Because those two sides are equal to each other. They are both equal to x plus y, therefore they are equal to each other. So we found out that side AB equals to side AE, and we have the rule that in front of equal sides in the triangle there are equal angles. In front of those two sides, we have those two angles that must be equal to each other. Why? Because they are located in front of equal sides. That is to say, angle theta must be equal to 20 degrees. So we found out that the size of this angle theta, it is equal to 20 degrees. Then I presented to you the second method. In the second method, we focus on triangle ADC. This angle equals to 80 degrees. This angle equals to 40 degrees. So the sum of those two angles is 80 degrees plus 40 degrees. The 80 degrees plus 40 degrees is 120 degrees. So in order to complete the sum of the angles in this triangle ADC to 180 degrees, this angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is 180 degrees. So this angle must be equal to 60 degrees. We define side AD as A. Then I presented to you the law of sines, and we implemented the law of sines in triangle ADC and triangle ABD. According to the law of sines, this is triangle ABC that could be any triangle. A over sine A equals to B over sine B equals to C over sine C. Then we implemented the law of sines in triangle ADC. According to the law of sines in triangle ADC, AD over sine of 40 degrees equals to AC over sine 80 degrees, and it is equal to DC over sine 60 degrees. Okay, then AD equals to A, so we substitute AD by A, AC equals to Y, we substituted AC by Y, and DC equals to X, so we substituted DC by X, and we got this equation. And those two expressions are equal to each other, therefore we can define the free expression as K. They are all equal to K. Then we derive the first equation, so this expression equals to K. And here we multiplied this equation number 1 by sinus 40 degrees, and we found out that A equals to K times sinus 40 degrees. Then we derive the second equation that x over sinus 60 degrees equals to K. Here x over sinus 60 degrees equals to K. We multiply this equation number 2 by 60 degrees, and we found out that x equals to K times sinus 60 degrees. Then we have the third equation. Those two expressions are equal to each other. So y over sinus 80 degrees equals to K. We multiply this equation by sinus 80 degrees, and we found out that y equals to K times sinus 80 degrees. So here BC is one side of triangle ABC, therefore it is absolutely a straight line, and we know that the sum of the angles on one side of the straight line equals to 180 degrees. So if this angle is 80 degrees, this angle must be equal to 100 degrees. Then we implemented the law of sines in this triangle ABD. So in this triangle ABD, according to the law of sines, we get that AB over sinus 100 degrees equals to AD over sinus theta. Again, AD over sinus theta equals to AB over sinus 100 degrees. AD is A, so we substituted AD by A, and AB is x plus y, so we substituted AB by x plus y. And we got that according to equation number 2, A over sinus theta equals to x plus y over sinus 100 degrees. Then we substituted A by the value that we found for A, we substituted x plus y by the values that we found for x plus y, and we got this expression here we divided this equation by k. We have k on both sides, so the equation, so we divided this equation by k, and we found out that sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. We cross multiplied this equation, and we found out that sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 80 degrees plus sinus 60 degrees. We divided this equation by sinus 80 degrees plus sinus 60 degrees, and we found out that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Then we have the trigonometric identity that sinus 2a equals to 2 sine a cosine a. We use this trigonometric identity in order to find out the value of sinus 40 degrees. Sinus 40 degrees equals to sinus 2 times 20 degrees. And according to this trigonometric identity, sinus 40 degrees equals to sinus 2 times 20 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Then we have the trigonometric identity that sinus 20 degrees plus theta equals to cosine theta. Therefore, sinus 100 degrees, that is equal to sinus 90 degrees plus 10 degrees, will be equal to cosine 10 degrees according to this trigonometric identity. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees, while sinus 40 degrees equals to 2 sine cosine 20 degrees times 2 times sine 20 degrees times cosine 20 degrees. Therefore, we can substitute sinus 100 degrees by cosine 10 degrees, and we will substitute sinus 40 degrees by 2 sine 20 degrees times cosine 20 degrees. Therefore, we found out that according to equation number 2, sinus theta equals to 2 sine 20 degrees times cosine 20 degrees, that is actually sinus 40 degrees. And we substituted sinus 100 degrees by cosine 10 degrees, and all divided by sinus 80 degrees plus sinus 60 degrees. We have the trigonometric identity that sinus d plus c equals to 2 times sinus d minus c over 2 times cosine d plus d minus c over 2. Then we use this trigonometric identity in order to find out the value of sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus d plus c is 80 degrees plus 60 degrees, that is 140 degrees, and 140 degrees over 2 is 70 degrees, times cosine d minus c. D is 80, c is 60, so 80 minus 60 is 20, 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. So we substitute sinus 60 degrees plus sinus 80 degrees by 2 times sinus 70 degrees times cosine 10 degrees, and we found out that sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees over cosine times cosine 10 degrees, and we substituted sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. Here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 also will get cancelled. And we got the expression that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. We have the trigonometric identity that sinus 90 degrees minus theta equals to cosine theta. We use this trigonometric identity for sinus 20 degrees, so sinus 70 degrees equals to sinus 90 degrees minus 20 degrees. And according to this trigonometric identity, sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. Therefore, we in conclusion found out that sinus 70 degrees equals to cosine 20 degrees. That is to say, we can substitute sinus 70 degrees in equation number 2 by cosine 20 degrees. We did it, and we got that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees. And we substituted sinus 70 degrees in the denominator by cosine 20 degrees. And we got that sinus theta equals to sinus 20 degrees times cosine 20 degrees over cosine 20 degrees. We have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled. And in conclusion, we found out that sinus theta equals to sinus 20 degrees. If sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that the size of this angle theta, it is equal to the size of this angle theta, it is equal to 20 degrees. Okay? Thank you very much.